We're combining different mathematical functions kernels to model data using Gaussian process. Regression. Think of it like mixing different ingredients to create a perfect recipe. I need to blend two specific kernel types, the radial basis function RBF kernel and the linear kernel, making sure the RBF kernel has twice the influence. It's like making a smoothie where I want double the amount of bananas RBF compared to strawberries. Linear. This is one of my kernel types. RBF stands for radial basis function. It's a type of mathematical function that measures similarity between data points based on their distance. This is my other kernel type. It's a simple function that measures similarity based on the linear relationship between data points. Think of it as a straight line. I need to carefully balance these kernels. The RBF kernel should have twice the impact as the linear kernel in my final model. It's like having twice as many bananas in my smoothie recipe. This combines the kernels equally, ignoring the 21 weighing requirement. It's like mixing equal amounts of bananas and strawberries. Not what I want. This doubles the weight of the RBF kernel, giving it twice the influence. I am almost there, but it's not perfectly normalized. This is analogous to adding twice the number of bananas in the smoothie recipe. This halves the weight of the linear kernel, achieving the 21 ratio. Similar to option B. This gives me the correct ratio but isn't normalized. This is like using half the number of strawberries in my smoothie. This option uses the weights 13 and 23 for the RBF and linear kernels respectively, ensuring the 21 ratio and the sum of weights equal to 1. This is the perfect normalized combination, the best smoothie recipe. We're building a model using scikit-learn's say as interpret as characters Gaussian process regresses as, which needs a special kernel. I want to combine two kernel types, a radial basis function RBF kernel and a linear kernel. The RBF kernel should be twice as important as the linear one, that's the 21 weighing. This problem is all about figuring out how to tell scikit-learn to do that correctly. Break time 300 milliseconds. Here, I am using a say as interpret as characters CompoundKernel say as to mix the RBF K1 and linear K2 kernels. I've given the linear kernel half the weight of the RBF kernel 0.5 K2, which achieves the 21 ratio. This is a valid way to solve the problem. Google style name lively, it's one of the correct answers. Google style break time 300 milliseconds. In this option, I am also using a say as interpret as characters CompoundKernel say as, and I've assigned weights of 1/3 and 2/3 to the RBF K1 and linear K2 kernels, respectively. This ensures the 21 ratio while also making sure the weights add up to 1, which is generally preferred for a properly normalized kernel. Google style name excited, this is the best answer. Google style break time 300 milliseconds. This is incorrect. It combines the kernels without any weighing, both kernels get equal importance. That's not what the problem asked for. Break time 300 milliseconds. I am weighing the RBF kernel twice as much as the linear kernel here, 2K1. However, the weights don't add up to 1. While this gets the desired ratio, it's not normalized properly for a say as interpret as characters CompoundKernel say as break time 300 milliseconds. Here, I define abbreviations. K1 stands for the radial basis function RBF kernel, and K2 is the linear kernel, break time 300 milliseconds. This section introduces the core concept. We're learning how to combine different types of kernels in scikit-learn, a popular Python library for machine learning. Think of kernels as ways of measuring similarity between data points. By combining them, We can create more flexible and powerful models. Break time 300 milliseconds. I am going to explain the task. I want you to create a special kernel by blending two standard kernels. Using scikit-learn's CompoundKernel. One will be an RBF radial basis function kernel and the other a linear kernel. The goal is to make the RBF kernel's influence twice as strong as that of the linear kernels. Break time 300 milliseconds. This option shows me a way to combine kernels. The RBF kernel K1 is multiplied by 2, meaning it's weighted twice as heavily as the linear kernel K2. However, that's not perfect because it is not normalized. Break time 300 milliseconds. Here's another approach. I am keeping the RBF kernel K1 as is and scaling down the linear kernel K2 by half. This also achieves the 21 weighing between the kernels. Still, this isn't perfect as it is not normalized either. Break time 300 milliseconds. This option is the best one. The weights 13 and 23 maintain the 21 ratio between the RBF and linear kernels, but also add up to 1. So they are properly normalized. This is important for ensuring the combined kernel behaves predictably. Break time 300 milliseconds. These are the steps involved in solving the problem. First, you must identify the kernel types. An RBF kernel and a linear kernel are used in this example. Second, you are given that the weight ratio between the two kernels must be 21. Finally, using the information given, you must correctly apply the weights to the compound kernel to reflect the desired ratio and produce a correctly normalized result. Break time 300 milliseconds. We're learning about combining different types of kernels in the scikit-learn library, a powerful tool for machine learning. Specifically, we'll focus on combining kernels to improve our model's ability to fit data. The core challenge is to create a combined kernel. Say as interpret as characters compound kernel. Say accessing a radial basis function kernel. Say as interpret as characters RBF. Say as in a linear kernel. The say as interpret as characters RBF. Say as kernel needs to have twice the influence of the linear kernel. This option represents the best solution. I am using say as interpret as characters 1. Say as for the say as interpret as characters RBF. Say as kernel and say as interpret as characters 2. Say as for the linear kernel. I've assigned weights of 1/3 to the say as interpret as characters RBF. Say as kernel and 2/3 to the linear kernel. This ensures the say as interpret as characters RBF. Say as kernel's influence is twice that of K linear kernel, and the weights add up to 1 1 3 2 3 1, giving a properly normalized compound kernel. This is the most mathematically sound way to represent the 21 ratio. Here, I am giving the say as interpret as characters RBF. Say as kernel. Say as interpret as characters 1. Say as twice the weight of the linear kernel. Say as interpret as characters 2. Say as. While this achieves the desired 21 ratio, the weights don't add up to 1. Although Google style name excited scikit-learn Google style can handle this. Option D is better because it's explicitly normalized. In this case, I am reducing the weight of the linear kernel to half while keeping the say as interpret as characters RBF. Say as kernel's weight at 1. Like option B, this gets the 21 ratio but isn't normalized. Again, while it works, option D is preferred for better clarity and mathematical rigor. This simply states the desired weighing scheme. The say as interpret as characters RBF. Say as kernel should have twice the influence of the linear kernel in the final compound kernel. This option is incorrect because it gives equal weights to both kernels, ignoring the problem's requirement for a 21 weighing ratio. Both kernels contribute equally. which is not what the problem requires. These are the 4 different ways of combining the kernels using say as. Interpret as characters compound kernel say as in scikit-learn. Each with a unique weight assignment to the say as interpret as characters RBF say as in linear kernels. We need to choose the option that correctly implements the 21 weighing scheme. We're using scikit-learn, a popular machine learning library in Python, to work with kernels. Kernels are mathematical functions that measure the similarity between data points. This problem focuses on combining different types of kernels. This option creates a compound kernel by weighing the RBF kernel K1 twice as heavily as the linear kernel K2. I think of it like this: imagine you are mixing 2 colors of paint. This option uses twice as much of the first color as the second. Google style name conversational. It's a good start. But we'll see why it's not perfect. Google style. Here, we're using 1 part RBF kernel and half a part of the linear kernel. Again, Google style name excited think of paint. Google style we're using equal parts of the first color, and only half as much of the second. Google style name conversational. This also gets us close to the desired ratio. Google style. This option creates a compound kernel with weights of 1/3 for the RBF kernel and 2/3 for the linear kernel. Google style name enthusiastic. This is the best choice because it keeps the desired 21 ratio Google style while ensuring the weights add up to 1. Think of it like a recipe where the ingredients are accurately measured to make a perfect dish. Break time 300 ms. The total weight of ingredients is important for the recipe to work properly. Break time 300 ms. Similarly, the total weight of kernels should ideally add up to 1 for a better performing model. K1 is shorthand for the radial basis function kernel. It's a common kernel used in Gaussian processes. It measures similarity based on the distance between data points. K2 represents the linear kernel. This kernel simply measures the similarity as a linear function of the input features. I am combining different kernels to create a more powerful model. Think of it like mixing different ingredients in a recipe to get the perfect flavor. The compound kernel is the mixing bowl where I am putting my ingredients kernels together. This option gives the radial basis function kernel K1 full weight and the linear kernel K2 half weight. Google style name conversational. This achieves my desired 21 ratio. But it's not perfectly normalized Google style. The total weight isn't 1. But the RBF kernel still contributes twice as much as the linear kernel. This option gives the RBF kernel 1/3 weight and the linear kernel 2/3 weight. Google style name excited. This perfectly represents the 21 ratio and adds up to 1. I want to consider this answer the best Google style. It's mathematically sound. It's a perfectly balanced, normalized combination. I am tasked with combining 2 types of kernels, a radial basis function RBF kernel and a linear kernel. The RBF kernel needs to be twice as influential as the linear kernel in the final model. Here, I am doubling the weight of the RBF kernel K1 while keeping the linear kernel's K2 weight at 1. Google style name emphatic. This gives me the correct ratio Google style. But the sum of weights is not 1. It is still an acceptable solution though. This option simply combines the kernels without any weighing. The RBF and linear kernels contribute equally, not the 21 ratio I am aiming for. This is not the solution. I am selecting the most effective way to combine my kernels using CompoundKernel in scikit-learn, ensuring the RBF kernel's influence is twice that of the linear kernel. This problem asks you to build a special mathematical function, a kernel that blends 2 simpler functions, one called an RBF kernel, and the other a linear kernel. I want the RBF kernel to have double the impact of the linear kernel in the combined function. Here, I am using scikit-learn's CompoundKernel to combine the kernels. I represent the RBF kernel as K1 and the linear kernel as K2. I am multiplying K1 by 2, giving it twice the weight of K2. This directly reflects the problem statement's requirement. However, it's not perfectly normalized. In this option, I again use CompoundKernel. I keep K1 RBF kernel as it is but reduce the impact of K2 linear kernel by half multiplying by 0.5. This achieves the same 21 ratio as in option B, but from a different perspective. Again, it lacks perfect normalization. This option uses normalized weights to get a 21 ratio and make the weights add up to 1 normalization. I assign the RBF kernel K1 a weight of 13 and the linear kernel K2 a weight of 23. Google style name excited. This is the best answer. Google style break time 300 milliseconds. It satisfies both the weighing and normalization requirements for a proper compound kernel. RBF stands for radial basis function. It's a type of kernel commonly used in machine learning. Think of it as a function that measures similarity between data points based on their distance from a center point. The linear kernel is a much simpler kernel. It measures similarity based on the dot product of the data points. It essentially assumes a linear relationship between your input and output variables.